Hey, welcome back again. The topic of the day, topic du jour, if you will, if you're French, is the naming of oxyanions and, by extension, a few of their acids. So, if you don't care, stop watching. It's interesting. If you do care, it might enrich your experience and understanding of nomenclature in general. So, here we go. First of all, do you know what some of the polyatomic ions are? These are good to memorize. Acetate's very common. Ammonium, one of the very few positive polyatomic ions, good to know. Carbonate, good to know. Chromate and dichromate, good to know. These are the bonding, and they got a chromium in the middle and 4 oxygens, or if 2 of these come together, they call them a dichromate. So eliminate one of the oxygens here and bond it with another. Well, take this one off, bond it with another oxygen attached to a chromate. Dichromate, can you see it? Cyanide, good to know. Sulfate, good to know, although if you follow along in the next few minutes, I'll tell you why. If you know sulfate, you know sulfite. And if you know chlorate and chlorite, you know hypochlorite, that'll follow along in a pattern as well. Nitrate's good to know, but if you know nitrate, you know nitrite. Very similarly named, but of course, and they look similar, but one fewer oxygens. Hydroxide, very good to know hydroxide, especially in Gen Chem 2. But in any case, here we go. Here's a pattern. Check this out. Imagine this if you can. Chemistry is all about looking for patterns. So I start in the middle with my 8 ion. A common, I'm not sure I know the history of all these, how they were named or discovered, but in any case, phosphorus containing oxyanion, very common. Phosphate has a 3- charge. Later on in the next unit, we might talk about how you could predict what the bonding in phosphate might look like. It's kind of a covalently bonded polyatomic ion. The phosphorus and oxygens are held together by sharing electrons. In this group, PO4 has 3 extra electrons. But go one more oxygen above phosphate and it's called perphosphate. Or, conversely, 1 oxygen less than 4 oxygens is 3, which is called phosphite. 1 oxygen less than that is called hypophosphite. And it's actually, honestly, a bit of a coincidence that they all have 3 minus, 3 minus, 3 minus, 3 minus. Oh, perhaps I shouldn't say coincidence. It seems to be a trend that eliminating, adding, or removing oxygens still often maintains a constant charge, but it's a bit of a coincidence that this 3 minus and this 3 minus are equal, because phosphorus as an element is in the 3 minus family, sort of, maybe, kinda, along with nitrogen. Anyway, that's called phosphide with no oxygens at all. I drew a line there, no oxygens. The acids, if you know phosphate, you should remember also phosphoric acid. 8 becomes ic as an acid. Phosphate, phosphoric acid. The phosphite becomes phosphorus acid. Ic acid, us acid. And then the hypophosphite would be hypophosphorus, and the perphosphate would be perphosphoric acid. Now this is interesting and confusing, that this H3P as an acid would be named hydrophosphoric acid, which seems a little bit screwy. Why wouldn't you call this hydrophosphoric acid? Just trust me, I'm not responsible. I'm just the messenger. Interesting, same pattern here. Is that going to be too big? That's alright, I can see that. Yeah, I hope you can see that. So here I have the chlorate, the common chlorine containing oxyanion. Chlorate, perchlorate, 1 more oxygen. Chlorite, 1 fewer oxygens. Hypochlorite, 1 still fewer oxygens, and no oxygens, chloride. Seems like by the previous example, analogy and trend. You might call this hydro. Oh, I did. I'm confused. Yeah, in any case, this is a confusing topic. Chlorate becomes chloric. Chlorite becomes chlorus. Perchlorate, perchloric. Hypochlorite, hypochlorus. And hydrophosphoric, hydrophosphorus, chlorine, hydrochloric. I guess that makes sense. I confuse myself when I overthink it too much. Look for patterns. Here's one I've written down. I think I wrote this out in terms of the acids a little bit more extensively, a little bit further down. It is good to know, as you probably have heard, the strong acids, hydrofluoric, hydrochloric, hydrobromic, hydroiodic. Memorize these formulas and their names. That is hydrofluoric, hydrochloric, hydrobromic, hydroiodic, acid, aqueous, but they actually came from the dissolution or the dissolving of these HF molecule, HCl molecule, HBr molecule, HI molecule as gaseous quantities, entities. Hydrochloric, hydrobromic, hydroiodic, sulfuric, nitric. Let's do the same. Where did phosphate? Yeah, we did. We did phosphate. Let's move on. Again, know your strong acids. Why do I say that so much? I wonder if it's very important. That's weird. Sarcasm. Where'd that come from? Don't look at that. I gotta delete that. Here's the sulfate again. Sulfate, sulfuric, sulfite, sulfurous, hyposulfite, hyposulfurous. We're going more than sulfate. One more oxygen per sulfate, per sulfuric, and this would be hydrosulfuric. Hydrosulfuric acid, although it comes from the dissolving of H2S gas as a molecule into water. This is actually a weak acid in water. This is actually a strong acid. That's a kind of a long story too. I drew this pattern out. I wonder if you like it. Maybe you don't. Maybe you already don't like my videos in the first place. Thanks for watching them. Here's my root oxyanion with the ending 8. And if you know a few of those like sulfate, nitrate, phosphate, carbonate, etc. You could try this with carbonate. I didn't write down carbonate. You can try it. Try this game with carbonate, naming the carbonic acid. If I add one oxygen per prefix above the in front of the 8, right? So perchlorate, persulfate, perphosphate. Subtract one oxygen, you get the ite ending instead of the 8 ending. Subtract another oxygen, you get hypoite. I didn't write the ite, but going ite and then go one below that, the prefix. Or if you have no oxygens, it's usually called ide, sulfide, nitride, phosphate, carbide, you name it. Boy, if you were ambitious right now, you'd pause this little video and try this naming scheme with the nitrate ion and other fewer oxygens and more oxygens and naming the acids. And I'll give you time to pause it right now. Or not. Here's the answer. At least the way I see it. Nitrate, NO3 minus. You should know that ion. No nitrite. Nitrate gives nitric acid. Per nitrate, one above that, one more oxygen. Per nitric acid. Nitrite, one fewer oxygens. Nitrous acid. Hyponitrite gives hyponitrous acid. And in a similar vein, HNO3, not to be confused with NH3, which is, what are you talking about? Hydronitric acid. I was going to say something and I forgot what it was. How terrible. Well, in any case, I'm getting old. So practice this a little bit if you feel like it. Come with questions, but not too many. I'm kidding. As much as you want. As much as I can answer. This is some of the trends I've seen in naming oxyanions and their acids. Although the naming of the acids is sometimes inconsistent and confusing. Thanks guys, see you in class. or discussion, or the hall, or the sidewalk.